Good morning, students. Today we will discuss next chapter of our subject, that is engineering graphics and modeling through AutoCAD. The topic of today's lecture is projection of solids. As in the previous lectures, we have studied the types of projection, then we have studied the projection of points, projection of lines, and projection of solid planes. Now we will discuss about projection of solids. So what is a solid? A solid is a 3D object. If we talk about solid in engineering graphics, we will consider only regular solids. So dear students, what is regular solids? Regular solids are those solids which can be categorized or explained by a general definition. So, these are some diagrams of solids. If we broadly classify the solid, then we can classify the solid as polyhedrons and solid of revolution. Here in this diagram, you can see square prism and square pyramid. Both of these are category of polyhedrons. Polyhedrons means solid bounded by planes. So you can see that square prism and pyramid are solid which are generated by combining number of planes together. The other category of solid is solid of revolution. Cylinder and cone are the examples of solid of revolution because these two solids are generated by revolving a plane about one of its side. So a cylinder is generated by revolving a rectangle about one of its side, while a cone is generated by revolving a right angle triangle by keeping one of its perpendicular side as axis. So, if we talk about solids, prism, pyramid, cylinder and cone are the categories of solid. Depending upon the sides or on the base of a solid, prism can be classified as triangular prism, square prism, pentagonal prism and hexagonal prism. Similarly, depending upon the number of sides in base, pyramid can also be classified as triangular pyramid, square pyramid, pentagonal pyramid and hexagonal pyramid. So, first we will get familiar with the terms used in solids. If we talk about now, if we talk about a square pyramid prism, the following terms must be understood. Say this is a square prism. So this is the top of a square prism. These are the faces of rectangular faces of a square prism. These are called vertical edges or longer edges. These are the corner of the base and this is the base of a square prism. And these are the edges of the base. Similarly, this is a square pyramid. This is the apex of a square pyramid. These are the slant edges of a square pyramid. This is the base of pyramid and this is the base edges of a pyramid. Okay. Now this is a cylinder again and this is a cone. Cylinder has two bases, both are circular. In a cone we have got one base and a apex point. Okay. So generators are the imaginary lines which are used to generate cylinder and cone. Okay. Now if a solid is cut by a cutting plane at some angle, then The regular solids are called truncated solids. These are section of solids of cone, cylinder and pyramid. And if we cut the cone, cylinder or pyramid by a cutting plane parallel to base of the cone, then they are called frustum of solids. So this is frustum of pyramid and this is frustum of cone. Now, while observing front view, XY represents horizontal plane. You all know that if a solid is kept on its base in HP, this is the front view of a solid. Here, the axis of the solid is perpendicular to HP or parallel to VP. Here, in the second case, the solid is resting in HP on its either side or corner and the axis is inclined to the HP and is parallel to the VP. And here, if a solid is resting in HP on its slant edge or vertical edge, then again axis is inclined to the HP. Similarly, while observing the top view, if the base of the cone is parallel to the VP, then the axis is perpendicular to the VP. In second case, the top view shows that the axis of the cone is inclined to the VP. And in the third case, the slant edge is resting in VP or slant face is resting in VP and the axis is inclined to the VP. Okay. So, while drawing the projection of the line, any one of these cases may be given in the problem, which we have generalized in this PPT. Now, we will start the projection by considering a problem. A square pyramid, base 40 mm, side and axis 60 mm long, has a triangular face on the ground, and the vertical plane containing the axis makes an angle of 45 degree with the VP. Draw the projection of the line. Draw its projection. Take apex near to the VP. So this is the problem of a square pyramid. Okay, we will start by drawing a line XY. Now in the first step, as it is given that a triangular face is resting on the ground, we will draw the top view of a square pyramid by keeping one side of base perpendicular to VP. And we will draw the square and we will join the apex point to all the corners. So this is the top view of a square pyramid. Now we will mark its base as A, B, C and D and apex point as O. Now in second step we will draw its front view by projecting the base on the front view and axis in the front view. Now this is the front view of a square pyramid. In third step we have to keep the triangular face on HP. So we will copy the step 2 in step 3 in such a way that the triangular face OCD, which is the line in front view, that is O dash, C dash, D dash, we will copy the step 2, the figure in step 2, that is a triangle in step 3 by keeping O dash, C dash, D dash on XY line, which means the triangular face is lying in HP. In the step 4, we will draw vertical projectors from front view and horizontal projectors from top view. And we will locate all the points of pyramid like A, B, C and D. Now, for drawing, joining all these points, we must remember that when we see a solid, all the edges of solid cannot be seen simultaneously. So, we will draw the lines which are visible to us using solid lines, and the lines which are not visible to us will be drawn using dotted lines. So from the top we can see the base of the pyramid. So we will first complete the base using dark line, then outer boundary, okay, and as OC and OD lies on the bottom of pyramid, so they will not be visible from top, okay. So in this way we will draw the final top view of a square pyramid which is resting in HP on its triangular face, and we will do the nomenclature as shown in figure. Now again it is given that the axis is also inclined at 45 degree to the VP. So in step 5 we will copy this step 4 by keeping 2 points in mind. First, we must keep the apex towards the VP, matlab near XY line, and the axis should be inclined at 45 degree. So, we will copy this figure 4 in figure 5 by keeping apex point near to XY and the line of axis inclined at 45 degree, like this. So, step 5 is always a copy of step 4 at the given condition. So, we have copied the step 4 as per the requirement of our problem, which says that point O should be near to the XY and the axis should incline at 45 degree. For drawing the final projection, we will draw projectors from all the edges of our top view. Vertical projectors are drawn from top view, like this is the projector from point D1, this is the projector from point A1, this is the projector from point C1, and this is the projector from point B1. And finally, this is the projector from apex point O1. Now, from third step, that is the front view, we will draw horizontal projectors to cut the previous drawn projectors, and we will mark the point by point of intersection of A1, B1, C1 and D1. Okay, like this. A1, B1, C1 and B1. Now, for joining the point, as the base is away from XY line, so this base will be visible in the front view. So first we will join this in the outer boundary like this, and as OD O1 A1 is towards the XY line, so this line will not be visible in final view, so we will draw this line using dotted lines. So in solid, we have to remember that whichever line is not visible to us, it should be drawn by dotted lines. Okay, we have taken again a problem of a cone, because in cone there are no edges because of a smooth surface. So we will again consider a problem. A cone 40 mm diameter, that is the base of cone, and 50 mm axis is resting on one of its generator on the HP, which is making an angle of 30 degree with the VP. Draw its projection. So we will start from the top view, considering that the cone is resting in HP. From its center point, we will draw a front view. For projecting a cone, we will divide the top view of a cone in 8 equal divisions. This is required so that we can draw the projection of a cone. So this is the front view of a cone. Okay. So we have prepared the top view of a cone, and we have divided the top view, that is circle, into 8 equal parts. In front view, we have projected all these 8 divisions to the bottom of the cone, and we will join all these using 3H pencil to the apex point. These lines will help us in projecting the cone when it is inclined to HP or VP. So, this is the front view and top view of a cone. Now, as given in the problem, this cone is resting in HP on its generator. So, in step 3, we will copy step 2 by keeping O dash E dash, that is the generator, on XY line. Say, see this, O1, O dash, E dash is kept on HP, and this is the copy of second figure. Okay. Now for top view, we will draw projectors from all the 8 divisions on the base of the cone like this. Similarly, horizontal projectors will be drawn, and by locating the point of intersection, we will draw the base of the cone, which now appears as an ellipse. Okay. And from point O, we will draw a tangential line to join this ellipse. Okay. So this is the final top view of a cone when it is resting in HP on its slant edge. Again, it is given that the axis of the cone is inclined at 30 degree to the VP. So in step 5, we will copy the step 4, that is the top view of a cone, in step 4 at a given condition, that is inclined at 30 degree to the VP. By keeping the apex point towards XY line, we have copied the figure 4 in step 5. Again, for drawing the final front view, we will draw projectors from all these 8 points of the base like this, vertical projectors from top view and horizontal projectors from front view to intersect at a given point, and we will locate all these points. We will also draw a vertical projector from point O1, that is apex point. Okay. Now, as the base of cone, that is ellipse, is away from XY line in top view, so this base will be visible in front view. So we will mark all the points and we will draw all these points using a smooth curve. This is an ellipse. From point O1, that is the apex point, we will draw tangential line on this ellipse. So we will get the outer boundary of the cone, and this is how the projection of a cone will be drawn. Okay, so we have seen a difference between a cone and pyramid. As in case of cone, no slant edges are available and generators are imaginary line. So in case of cone or cylinder, for drawing projection, we have to divide the base of the cone in 8 equal parts so that we can draw its projection in later stages. Okay. Here again a problem of cube is given. Okay. By using the similar method which we have drawn in case of pyramid and cone, the projection of cube can also be drawn. You can go through the problem. A cube of side 50 mm is given, and it is so placed that the diagonal, body diagonal, which is the solid diagonal of a cube, is perpendicular to VP. Okay, so draw its projection. So we will start from the top view. We all know that a cube has 6 faces and all the faces of cube are square. So as we have to keep the solid diagonal perpendicular to VP, so we have kept the cube with its faces equally inclined to VP. This is the top view of a cube, and ABCD are the points. Now we will draw the front view of a cube by projecting projectors. Okay, and this is the front view of a cube. Okay, now the solid diagonal is a diagonal which is joining the one corner of base to the opposite side corner of its top. So we have joined a line, and this line is a solid diagonal. Okay, Now, a cube has two bases. So, for one base, we have marked the point as A, B, C, D, and for other A. For making the solid diagonal perpendicular to VP, first we have to make it parallel to HP. For that, we have done a construction from point 1 dash. We have drawn a perpendicular line on solid diagonal, that is 3 dash C. By keeping this line vertical, we can draw step 3 in such a way that the 3 dash C line becomes parallel to XY as shown in figure. See, here we have kept the solid diagonal perpendicular to VP. Now, for top view, we will draw the projectors from front view like this and horizontal projectors from top view like this. We will mark all the point and we can see that when we see it from top, ABCD base will be visible, so it is made dark, and the bottom will not be visible, so it has been drawn using dotted lines. Okay. Now here the solid diagonal 3C1 has become parallel to VP. Now in step 5 we will copy the figure of 4 by keeping this solid diagonal perpendicular to VP as shown in figure, and by projecting all these points from top view and front view and joining using the concept of visible lines and invisible lines, we will get the final projection of a line. We will get the final projection of a cube like this. Okay. So this problem is important as this problem will set a concept for isometric projection. Okay, friends. So go through these problems. This is all about projection of solid. Thank you. Thank you very much.